Hello, so in this video we're going to talk a little bit about some double angle identities. Now, the most fundamental one that we look at in this chapter is cosine 2 theta, sine 2 theta, and tangent 2 theta. So we have that there are, for example, like cosine of 2 theta, which is said to be cosine squared theta minus sine squared theta. And then we have that, okay, so that should be a 2. We also have that sine 2 theta is equal to 2 sine theta cosine theta. We actually also have, as mentioned, the tangent 2 theta. Now that's going to be 2 tangent theta divided by 1 minus tangent squared theta. Now it probably would be best to leave this one and not try to implement a Pythagorean identity because that might make it a little more complicated. So because we have that this equation is with respect to just it's just the tangent. Now, if you want to show, for instance, like how are these equal to what we have here, I would recommend that you look at the equations like cosine of a plus b and sine of a plus b and then tangent of a plus b. But in this case, as you're kind of like expanding them, use when b is equal to a. So that's the only thing that you'll have to remember if you are going to try to prove these. You'll have to use that a is equal to b, hence the 2 theta. Now, from cosine 2 theta, knowing that that's equal to cosine squared theta minus sine squared theta, well, we happen to know that, for instance, that for sine squared, we have that that's going to be 1 minus cosine squared theta. But if we go ahead and we distribute, that's going to give us that we end up with cosine squared theta minus 1 plus cosine squared theta. But this means that that's going to be 2 cosine squared theta minus 1, which basically tells us that we have that there's another way that we can rewrite cosine 2 theta. It's as this equation over here. So we have another formula. So that's equal to 2 cosine squared theta minus 1. But we also have another double angle identity for cosine 2 theta. If we rewrite it in terms of sine, similarly, we kind of get the same thing. We have 1 minus 2 sine squared theta. So these are our other two equations or formulas. Okay, so let's look at an example where we try to use this formula for the double angle. Okay, now suppose that we go ahead and we look at, for example, the following expression. Okay, so what we want to do is we want to find sine 2 theta, cosine 2 theta, and while we're at it, let's just go ahead and find tangent of 2 theta. Now, we'll give you a bit of information. We'll say that sine theta is equal to negative 5 over 13 with the fact that cosine of theta is going to be negative. Okay, now when we look at this, we should automatically kind of think, well, I know, for example, that based on the definition, 'we' have that, 'we' have that 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 this part is going to be 5. Okay, so we have our theta. And then this part is going to be 13. But if we use Pythagorean theorem, we have that this is going to be 12. Okay, so the next thing is to determine based off of this quadrant. So we have negative and positive. So that tells me that in the quadrants, we have all students take calculus. So this means that sine is negative, so it's going to be negative, but cosine's also negative. This tells us that we're in the third quadrant. So let's go ahead and figure out how we can do this problem. So, okay. Now, we know that, for example, that we can find, let's see, sine 2 theta. So sine 2 theta accordingly is equal to 2 cosine theta sine theta. It doesn't matter which one came first. It's all the same. So here's what we'll do. We'll write that this is going to be 2 times cosine of theta, but that's going to be negative 12 over 13 multiplied by sine theta, which is negative 5 over 13. Now, when we multiply this through, we're going to get 120 divided by 169. So this is the solution to sine 2 theta. Now, I could probably solve for cosine 2 theta using either the formula again, uh, or we can use the Pythagorean theorem, whichever the case is for you. But what we'll do here is we'll just go ahead and say that, well, we know that cosine 2 theta equals to 1 minus 2 sine squared theta, which that's very convenient. So we have 1 minus 2 negative 5 over 13 squared, which gives us 1 minus 2 times 25 over 169, which is going to be equal to 1 minus 50 over 169, which this will give you 119 over 169. Okay, so I found cosine of 2 theta, but now I need to find tangent of 2 theta also. Now, interestingly enough, instead of using the formula that was written for tangent 2 theta, I already know what sine and cosine is, so why don't I just use the quotient identity where sine is divided by cosine of 2 theta. Okay, that's way easier. So we have 120 divided by 169 divided by 119, but also divided by 169. But this equals to 120 divided by 119, and that's it. Okay, so I only did that because I didn't want to go through the process of finding what tangent is with respect to just this sine theta. But notice that you could have still found it by using tangent theta is just 5 over 12, which means positive. Okay. Okay, so we were able to find all three of these double angles. Now, let's look at another example where we'll tell you that, for instance, that we have the following. So let's say that we have that cosine of 2 theta is equal to negative 3/5. Okay, now from here, we'll just kind of say that our theta is between 90 degrees and I believe it's 180. Okay, so what I want to do with this one is I just want to find the sine, cosine, and tangent. So this is pretty cool because, okay, so yeah, we want to find sine, cosine theta, and tangent theta. Okay, so these are our given conditions. So what this tells us is that essentially theta has to be, let's see, it has to be in the 45, um, well, it says it's between 90 and 180, so we got to be careful with this. Okay, so let's say that we go ahead and we use that cosine squared, or not cosine squared, but cosine 2 theta equals to 1 minus 2 sine squared theta. Okay, this is going to help us. So we have negative 3/5 equals to 1 minus 2 sine squared theta. Now, essentially this is telling me that sine theta is in the second quadrant, which means that it's positive. So this will give us the following. If we kind of rearrange some things, we have that this gives us that sine squared theta is equal to 4/5. All I did was I just kind of moved things around, like 1 plus 3/5. Yeah, that's going to be 8/5, and then divided by 2, that's going to be 4/5. So the next step is really just to take the square root on both sides. So we take the square root, and this gives us 2 divided by root 5. Okay, now you could rationalize this if you want to, but I mean, it's really up to you. So this is equal to 2 root 5 divided by 5. So, I mean, it's up to you entirely, like how you want to draw this diagram. So the next step would be that you would basically say that, well, you have your right triangle, and I'm actually going to go ahead and just say that this is going to be 2, and this is root 5, and this is my theta. And then using Pythagorean theorem, basically you're going to find, um, yeah, so you're basically going to find that, let's see, this should be, okay, so let's do 2 squared plus b squared equals to the square root of 5, but that's squared. So this should give me, yeah, it should give me 1. So I have that this will be 1, but it's going to be -1 because it's in the second quadrant. Okay, so the next step is that we just need to find um, what this is going to be. Okay, so now we'll just take that base from here that we can find the remaining trigonometric functions. So we have that this is going to be that sine of theta is equal to, well, we already found it. It was 2 root 5 divided by 5. So that's sine of theta. Now, all that we need to do is find cosine as well. So that's going to be cosine of theta is equal to -1 over root 5. But that's the same thing as negative root 5 over 5. So that tells me that cosine is negative root 5 over 5. But I also need to find the tangent. Now we can either do where we find the ratio of the two, but I don't think it really matters. So because we can see the diagram from here, that tangent of theta is going to be basically negative 2 over 1, and then that's going to be negative 2. So we've got the tangent of theta is equal to negative 2. Now keep in mind that you can actually use your calculator to solve for some of these, but sometimes it gets more complicated by using the calculator. Um, okay, so the other things of which that we can do, for instance, is to use double angle identities to help us. So let's say, for example, that we have uh, that, let's see, we want to basically simplify the following expression. So let's say that I have that sine of 2x is equal to 2 tangent of x divided by 1 plus tangent. Okay, so we'll just say tangent. Okay, so we have tangent squared x. Now, this is actually pretty interesting because I know that if I'm going to try to simplify that I need to change things to sine or cosine or corresponding Pythagorean identities. So I have 2 times sine of x divided by x, cosine of x, all divided by, well, this is really secant squared x. But I need to go further and say that this is 2 sine of x divided by sine of x. Well, really cosine of x, right? But what we can do here is just multiply by, let's see, notice that secant squared is the same thing as 1 over cosine squared x. So that's really cosine squared x all over 1. Now what this does is it tells me that one of the cosines definitely does cancel out. So we can do that. We can say that, okay, well, one of the cosines cancels out, and that's going to leave me with 2 sine of x cosine of x, and that's it. So notice that it basically gave me whatever sine 2x is equal to, but we know what sine 2x is equal to. It's equal to 2 sine x cosine of x. Now, similarly, you can do that for other types of expressions, for instance. Um, well, it's very similar to the double angle identity for sine 2x. So like you can probably use, for instance, like if you have sine of 3 theta and then you have cosine of 3 theta, this is the same thing as saying 2 over 2, and then you have sine of 3 theta, cosine of 3 theta, but this equals to 1/2 of basically you take the 2 sine 3 theta cosine 3 theta, and basically this just gives you 1/2 of sine of, let's see, that's going to be double, so that's going to be 6 theta. So essentially I used my double angle identity and kind of like manipulated it so that I could rewrite it in a different way. So that's kind of like what the remaining section looks like. It tells you to change some of the expressions. So be sure that you do read the product to sum. Okay, so be sure that you do look at the product to sum and the formulas that you have for those, and then we can start looking at the. You can also look at the sum to product, which I mean is more or less kind of like the same. You really don't use them though until like pre-cal or even cal 2. So if you happen to not really go through it that thoroughly, um, there won't be much of a loss anywhere. Okay.